Okay, so hello everyone. It's my pleasure to share this last session of this wonderful conference this afternoon. I am the backup chair for this session because Professor Zandrovarzak was ill. Oh, finger crossed that it's not coronavirus, but we'll see. So I replace him for today. So let's introduce the four speakers of today. Sylvain Bolifraud from CentraleSupélec. I've got the pleasure to supervise him for his PhD work. Darren Anthony Jones from United Kingdom, the Open University, working with Claudia Eckert, and Anthony's got some problem of connection, but Claudia is here to answer questions if necessary. Georg Otto Mueller from DTU in Denmark, and Timothé Sissoko, PhD from CentraleSupélec. I wanted also to say that we have one paper with your reviewer's favorite award in this session, and it's a paper of Darren Anthony Jones concerning managing margins over design in hospital building services. And this paper is evaluated as being of the top 10% rated papers by the reviewer's score. So congratulations. And the authors will receive the reviewer's favorite certificate after the conference. I wanted also to thank Robert for being our technical support helper today. Robert. So now Robert is going to play the pre-recorded presentation videos, and then we will spend times for questions and answers. So all people, do not hesitate to ask questions in the chat. Thank you.
Hello, I am Sylvain Bolifraud, and I will present you the paper written with Julie Le Cardinal and Jean-Claude Cryonnet. I am an industrial in construction industry, specialized in conflict resolution, and aside my job, I pursue a PhD thesis with CentraleSupélec. The central subject of the thesis is the contract and claim management in construction industry. Now, we are going to look how a better representation of contractual relations can help to find better contract. The problematic is as follows. Is it possible to give actors of a construction project a representation of the contractual relationship that allows them to improve the knowledge of the contract and the interaction they have with their environment? Construction projects are subject to a lot of evolution in the course of their realization. In construction, you manage the work to modify a property. You don't manage the design of a product which will be fixed at one moment and produced in series. In this situation, even if you get the best design ever, you can't refuse the decision from the owner to modify an element because he realizes that this modification would better fit his needs. Or maybe, as construction project can be very long, the market can change, or the owner can have won a new contract. So he needs new capacities he wants to implement in the course of the same project. Also, you will have to deal with, for example, unexpected soil condition, adverse weather condition, supply chain problems, epidemic. All these elements make that initial project well-designed, well-contracted, and with evolutions implemented in the course of the construction. Here we present two examples of the possible evolutions of a construction project. Elbs Philharmonic in Hamburg and Hyper nuclear plant in France. We just want to illustrate. We don't focus here on the root cause of evolution of these specific projects. We don't know if Hamburg citizens had the benefits of a public inquiry on the subject, but for the EPR, 2 public reports have been published to look the root cause of the deviation and to examine the public expenses. Our method consists in using NIAM for Natural Language Information Analysis method to represent the whole construction contract system based on definitions of different elements. We group these elements to analyze them in three groups. A, for relation between owner and contractor, B, for the relation between the contract and the parties, and C, for the construction process. Then we superpose these groups with the three environments of Boirel. After this identification, we look in existing literature, representation of these environments, and propose improvement to internal and external environment representation. For internal environment, the two main ways used to look at the contract clause is first the written contract, which can be difficult to understand for some on-site project manager, and second, the use of programming system in order to automatize contract management. This second way is very useful in little product buying contract. The third way is the use of logigram, but in literature, we don't find very formalized language, but more in-house notation system. We propose to use BPMN for business process management notation. The advantages is the adaptability of BPMN to a multi-organization project, and because of its normalized aspect, the possible coupling to BIM management system. For external environment, we propose a modification in the positioning on the way to look at the project for a project manager. This change in positioning transforms the contract from a simple entry in a mechanical process into a complete contract management process. The contract becomes at the same time a tool used to deal with changes and an element which need to evolve along the project. The two precedent propositions for internal and external environment have been presented in professional conferences, validated by FIDIC board members, and implemented and tested on project claim situation. Discussions are ongoing to implement the BPMN representation for FIDIC contract suite. In our paper, by exploring the root cause of conflict in construction contract, we determine that improving knowledge and understanding of contract is the true element to improve in order to reduce conflict. By exploring construction contract system representation, we were able to point out specific areas of concern, which need to be improved to give a better understanding of contract management mechanism and a better understanding of obligations. Finally, our propositions were tested and validated by independent professionals in construction contract management. Thank you for watching.
I am Darren Jones, a PhD student at the Open University, and this paper looks at overdesign in hospital building services and has been co-authored by my supervisors, Professor Claudia Eckert and Dr. Pam Garthwaite. NHS hospitals have very stringent energy efficiency targets to meet, whereby they need to achieve a net zero position by 2040. The NHS currently spends in excess of £560 million a year on energy, which is increasing year on year, and produces 3.7 million tonnes of CO2 annually. Hospitals have vastly oversized energy infrastructure and building service systems such as boilers, chillers, and ventilation systems. This oversizing causes an inherent efficiency issue, as the oversized systems are incapable of operating at their optimum point. Research for this paper was funded by the Centre for Digital Build Britain and focused on a case study at the John Radcliffe Hospital in Oxfordshire. The case study looked in detail at an energy infrastructure system that was upgraded during 2018, a system that was found to be vastly oversized. A mixed methods approach was adopted for the research, which included stakeholder interviews, a document analysis, and system modeling. As seen from the system model, the energy infrastructure upgrade was complex and included components such as boilers, a combined heat and power unit, absorption and electric chillers, and heat rejection systems. This slide provides a summary of research findings. The installed capacity of chilled water systems at 3.7 megawatts was significantly greater than the site chilled water demand at just 1 megawatt. The principal cause of the chiller over-design was due to the trust output specification. However, no rationale for this was obtained. From documentation provided, the design margins applied to the project could not be identified either. System redundancy provided by the steam boilers led to significant standing losses and associated costs. Preliminary calculations suggest that alternative systems may have provided overall greater value for money compared to the installed system. An example of an alternative design can be seen to the right of this slide. Reasons for the building services over-design was a result of numerous factors. Margins had been applied across the various specification, design, and installation phases of the project. Poor communications was also apparent across the various stakeholders. Rationale for the margins is to safeguard against uncertainties associated with current and future requirements and engineering risk, as well as to provide safety, flexibility, reliability, and resilience. The authors identified that design approaches are very often a result of custom and practice, and that industry published guidelines add to the problem by recommending various margins be added, rather than applying an aggregate margin to cover all risks. System energy savings was so impressive that the over-design was missed, and the rationale for this was lost over time. It was apparent that there was a clear lack of baseline data upon which to size the systems, and that the one-off funding opportunity led to an install capacity that took full advantage of the budget available, although it was not clear who was actually making the decisions due to the high turnover of senior management. Mitigation against oversizing and future work associated with this can be characterized into 4 key groups. Better information such as margins capture and site data is required, as is our better understanding of equipment part load characteristics. Improved design, looking at modular architecture, reduced margins and better communications, and avoiding like-for-like replacement of systems should be explored, as should considering redundancy outside of the main system. Adopting efficient processes is key to managing risk and preventing oversized systems. And finally, better training and education and the possible use of dedicated architects to manage communications between stakeholders should be considered.
Welcome to this presentation of our article with the title Towards Best Practices in the Engineer-to-Order Business, a Framework for the Structured Analysis of Commissioning Processes, written by me, Georg Mueller, and my colleagues Christiaan, Bertram, and Niels Henrik Mortensen from the Technical University of Denmark. Engineer-to-Order, or ETO products, differ greatly from mass-produced products. For instance, ETO product design is based on specific customer requirements. ETO products are typically highly complex and produced in low volume or even as one-of-a-kind products. Those characteristics influence the product development process as shown here. A product is designed based on customer requirements and then manufactured and assembled or installed. Before being able to use the product, though, it is necessary to commission the product, including the qualification or testing of its components, and also the ramp-up of the initial operation. The importance of the commissioning process or commissioning phase for the success of the whole product development is agreed upon in literature. Therefore, it is necessary to investigate the relation between product design and product commissioning. That investigation proves to be difficult due to a number of engineer-to-order characteristics. For example, ETO companies are usually organized in a project-based manner. Given the uniqueness of each product, every product development project is unique too. Furthermore, previous studies have shown a challenging data and information management being common in engineer-to-order companies. It is therefore necessary to develop an approach for the structured analysis of past product development projects by investigating product design and its impact on the commissioning process. In our analysis framework, the product development process is represented by three aspects. Given its influence on the success of the development project, the process structure of the commissioning of a specific product A is visualized, as well as the product structure as a visualization of the product design. Furthermore, since engineer-to-order products are designed based on specific customer demands, the product requirements are included in the analysis framework too. The goal of the framework is not only to enable the comparison of different unique product development projects, but also to allow for the identification of best practices. Therefore, it is necessary to include performance measures as well. In order to measure the performance of commissioning processes, two factors are identified based on the literature search: commissioning cost and commissioning time or duration. By mapping these 5 dimensions for multiple past projects or products, we enable the identification of patterns within commissioning processes and their impact on the commissioning performance. Additionally, it is possible to analyze the influence of customer design demands and design choices on the commissioning process. The developed framework for the analysis of product development project has been applied in collaboration with a case company. The company is developing and realizing complex one-of-a-kind production systems based on customer requirements following the engineer-to-order approach. So in this case, the designed product is a production system. In order to visualize the product requirements for each developed product, a radar chart is chosen as seen here. The specific product is then plotted onto this radar chart as shown in blue. The product structure is visualized as a block diagram featuring the main components or subsystems of the product and their interfaces. The visualization of the commissioning process is realized by highlighting the activities or tasks that need to be carried out to commission the specific product. Furthermore, durations and necessary resources are included in the overview as well. The duration of a commissioning project is visualized with a bar chart, including the estimated duration of the commissioning project as well as the actual duration. Similarly, the cost of each commissioning project is represented. By applying the developed framework for the analysis of commissioning processes in collaboration with the case company, it has been shown that a high-level comparison of product development project is, despite their uniqueness, possible in the engineer-to-order context. It allowed us to show the impact of product requirements and design aspects on the commissioning process and its performance. Furthermore, the visual representation of data and insights was well received when discussing the results with practitioners in the case company. The results that can be obtained with this analysis depend largely on data availability and data quality. Future research efforts should focus on overcoming the issues in information management that are typical for the engineer-to-order industry. Furthermore, the developed framework should be applied to more industrial cases to evaluate its feasibility and also the limitation of its application. Thank you very much.
Hello everyone, this is Timothé Sissoko. I am going to present a research conducted with my colleagues Marija, Jankovic, Chris Paredis, and Henrik Landel. It is entitled Efficient Data Gathering in Support of Design Issue Resolution in an Automotive Company. We are going to talk about data collection for a numerical tool embedded in a decision support framework that we designed. Let me first introduce this framework. Whereas classical approaches of decision-based design generally compute decision problems focusing on the design artifact, considering technical alternatives exclusively, we devised a framework that is an extension of a process-focused decision model proposed by Thomson and Paredis. In our framework, called the Issue Resolution Decision Support, we incorporate and make explicit process alternatives, such as performing further analysis concurrently and postponing the artifact decision. RDS was developed to address real industrial problems and was tested accordingly with the aim to be implemented in companies. When it comes to implement a framework involving numerical tools in an organization, a couple of challenges arise, and amongst them, the questions related to data gathering. From which source should we collect the data? What accuracy is acceptable? How difficult or costly is it to produce and collect data? How can we gather data more efficiently? If you see the thread, we are addressing questions related to value of information and sensitivity. In this study of implementation, we leveraged the knowledge gained in a previous empirical study and deployed RDS on 5 case studies. We first wanted to identify what data that is already commonly communicated in the current decision dossier can be used as RDS inputs. Then, we conducted interviews with data providers to elicit their beliefs on the missing inputs and also to estimate the resources consumption for data gathering. We computed the decision problems and performed sensitivity analysis to identify the most influencing inputs and draw conclusions about the accuracy that is acceptable. Of course, that was for us an opportunity to refine the method of analyzing decisions with RDS. There's 22 RDS inputs required per decision alternative. These inputs can be single numerical values, simple triangle distributions, or more complex functions. They concern costs, probabilities, rates, or durations. By analyzing 40 decision dossiers in addition to the 5 case studies, we observed that 5 to 20% of the numerical data that is already available in the decision dossier can be used almost directly as RDS inputs. These data are the very common costs and some insight on probability of success of a technical solution with regards to its performance. It is important to note that the data available only account for a positive outcome of the decision. It does not take into consideration a potential failure and the associated costs. Now we know what inputs are missing. Due to their nature, it is interesting to know where the available data are coming from. It happens that for one decision dossier, one same input can be filled with data that come from different sources. If, when we want to use RDS, there are several potential providers for the same input, which one should be prioritized? An expert may provide a more valuable insight than a simple analyst, hence a better input. However, the expert may not be easily available and may be more expensive. This is why we propose an efficient way to gather data to use RDS. As we just saw, some inputs can be extracted from the current practice. Instead of deploying important efforts to elicit experts' beliefs and perform costly numerical simulations, we propose to first put rough estimates in the model and perform sensitivity analysis to see what input can really change the decision. In some problems, one alternative is so dominant because of some inputs that gaining accuracy on other inputs won't change anything. This is insightful since it enables the decision analyst to save resources. In conclusion, what did we learn from this study? 5 lessons. 1. 5 to 20% of RDS inputs are already available in the current decision dossier. 2. Qualitative data can support belief modeling. You will find more detail on this topic in the paper. 3. Each RDS input can be supplied by multiple people and entities with different accuracies. 4. Upfront sensitivity analysis with rough estimates supports efficient data collection. And last but not least, RDS prompts data providers to communicate their beliefs explicitly and fosters critical thinking. Thank you very much. If you have any questions, see you in the virtual room or shoot me an email.
Thank you very much. So if you have any question to ask, please write them in the chat, and it will be a pleasure for me to share them with all the authors. Sylvain tried to come back with us. We will see if he managed or not. So I have a question for for Darren. Darren, thank you very much for your very interesting presentation. I was wondering because as I was a backup chair, I didn't take a lot of time to look at all your papers. But I was wondering how many systems did you model and which one did you model in the hospital?
Okay, so we modelled the main heating and cooling systems within the hospital to ascertain what was there and what the capacities and performances were of that system. We then looked at alternative models and we did engineering sketches of those and how they may perform had they been there in replace of the existing system. And what we found through engineering calculations was that the modelled systems, sorry, the alternative design systems may have provided better outcomes in terms of efficiency and capital cost, because there were fewer components. The system that was installed included CHPs, boilers, chillers, and it was hugely complex. So there was one main system model for the hospital as it currently stands, and I think we did 2 alternative design models to try and replicate, if they'd designed it differently, how that might have impacted on the old system.
Okay.
If that makes
sense. Thank you very much. Thank you for this clarification. Georg, concerning your work, if we go back to the matrix of commissioning, concerning the performance of commissioning, you address, you took into account 2 main criteria, cost and time. And I was wondering why didn't you take into account the quality of commissioning?
Thank you very much for your question. We were designing the framework. The quality of the final product was actually also part of it. The problem is that the quality was quite hard to quantify or to visualize. And also in the literature, it was agreed that the most important aspects to be covered for the success of a product development project were the cost and therefore also the duration. So we decided to leave out the quality for this framework.
Okay, I think you took into account risks, right?
Excuse me, sorry, I'm having a bad connection. Could you please repeat that?
Yes, so I understand for quality, but I think you took into account risks concerning commissioning.
Yeah, this is what we tried to cover by not only including the actual duration or cost, but also the estimated duration and cost for each of the product development projects, and therefore being able to investigate whether or not we had delays or overruns in cost, which of course will be effective for the risk analysis as well. Okay.
And another question specific for Timothe's work. So Timothé, you presented the different roles between analysts and experts.
Yes.
And I was wondering, how can we switch roles and responsibilities between both of them? How can we decide to take an expert or to take the analyst's expertise? How can we decide?
Good question. Actually, in the daily practice, this is constrained by the time that they can allocate. For instance, the experts are less reachable. But if you want to apply the framework, actually, if you see that the decision is really sensitive to some, to the accuracy of one data or a piece of information, the experts may provide a more accurate input
that will minimize the risk of making a wrong decision. You know.
Okay.
So basically, you can, yeah, it's about modeling the margin of error. I didn't cover that in the presentation, but this is basically what we did. And if it's reached a certain threshold, we want to investigate more about the input data.
Okay, thank you very much. Now, as we are in a decision-making support tools session, I have a global question for all of you, and I would like each of you to respond precisely compared to your work. So my question is, what kind of decision do you allow to make, and for who? I don't know who wants to start. Darren, maybe? Yeah.
Sorry, I didn't quite get the question. I think my
my global question is,
could you
what
repeat the
kind
question,
of
please?
decision do you allow to make? Does your work allow to make? And for who?
Yeah, I think I got that. Basically, the decisions we're trying to make is to establish the actual requirements that are needed for the hospital engineering systems, and to make the correct decisions. We're wanting to capture what those requirements are in some detail, which requires better data, better communications, and better understanding holistically of the design process, and to ensure that we don't include more margins that are necessary into the design, and therefore it doesn't become over-designed. So decisions that we're trying to achieve is, how do we better make decisions with regard to the design of the building service systems, and what we're trying to establish is what do we need to do to ensure that better decisions are made, and that's through better capture, as I've said, of data and communications across project stakeholders, to make sure that information is shared amongst the project team, and make sure that margins aren't applied above other margins that have already been applied.
Yes, it's really clear. Thank you very much.
Does that answer the question?
Yes. So, who next? George? Timothé?
I can go next. So, as we also said in the title, our framework is supposed to help with identifying best practices across the whole product development process in engineer-to-order companies. So, for the part of your question on who is going to be helped with this tool, that would be project managers and engineers who are part of the product development process. And the decisions could range from, should we start a specific project? Should we design a product in a certain way? All of it coming back to whether or not that decision will have an influence on the commissioning, and therefore an influence on the success of the product development project. So the identification of best practices is the key decision that will be supported by our tool.
And when you speak about engineers, it's much more a team of engineers?
Yeah, so that could be the whole teams of engineers. It could be the technologists, so the high-level engineers, as well as the detailed engineers that are in the component engineering. But it could actually also be sales engineers who have to decide whether or not to take on a new project, a certain new project. They could already compare the product requirements, so the customer demands that they are facing, with its influences on the commissioning success, and therefore on the product development success. So even early on in the product development process, we can identify potential problems and risks.
Okay, thank you, Georg.
Mhm.
Timothé, can you go on?
Yes. So the kind of decision that we're concerned about are actually the decisions that are made to solve design problems during the development phase of vehicles. And such decisions are made, in our case, by the project manager, so that is called the chief vehicle engineer, or the architect, which is a person that has a high level of hierarchy and control over the resources and the architecture. And the decisions can be, are threefold. They can concern the implementation of a technical solution to solve the design problem right away, to gather more information actively about a technical solution, or to wait that the design maturity evolves sufficiently to minimize the risk of rework due to the inconsistencies, because the design maturity of the vehicle keeps evolving all along the development project. Is that clear for you?
Okay. Thank you very much, Timothé. And I think we lost again Sylvain. So I can answer my question for Sylvain just to present a little bit more his work. So Sylvain addresses improvement of the contract process, how to improve the process of contractualization within a construction project, and he will serve the issues for the contractors and also the owners, which are in a relationship between this kind of construction project. Okay, so Darren, I've got a question for you from Sabah. Interesting work. The data you had in your paper on the scale of inefficiencies are substantial. Given that you conducted interviews to gather much of the data, how much do you think those same stakeholders understand the scale of the problems? Was it news to them to see your findings? And how do you think this awareness, willingness to change might change future decision-making or be a barrier to improvement?
Okay, well, thank you very much, Sylvain, for the question. It's an excellent question. So, yeah, as you say, these systems are sometimes 300 or 400% over capacity. And when we fed back the findings to the workshop of the enormous over-design of this chilled water system that we studied, I think it was a bit of a surprise to many. Some have experienced oversizing in building services previously, some of the NHS trusts, but I think to many it was a massive surprise. And I've had subsequent conversations with the people that attended the workshop to see how they can overcome the problem going forward. So I think it was very well received. And I think going forward, they will certainly be mindful of the issue of oversizing and how that impacts on energy efficiency. And hopefully, you know, the research will help inform NHS hospital trusts and other building owners as well, because this research doesn't only apply to hospitals, but over designing, it applies to many buildings across the building sector. And so it's going to inform a lot of people. So in short to your question, really, I think it was a very, very big surprise that the systems were so significantly oversized. And I think there's a real ambition to prevent this from happening going forward.
Thank you. Yes, very helpful indeed. Well, one question we ask very often concerning research works is how can you measure your efficiency or the performance of your proposition? And when I look at your titles, I can see better, I can see best, I can see efficient. So how can you be sure that you reach this goal? Did you measure some comparisons? Do you make interviews to see if people are more happy with what you proposed? It's once again an open question, but it's very important in our field to be sure that if we want to improve something, how can you measure this improvement? And it can be quantitative, but it can be also in a qualitative way. Is someone of you wants to answer this? It will maybe be the last question if we don't have any more, but I think it's very important to be aware of that.
Yeah, I can maybe go ahead if nobody else
Yes.
jumps to the front. I think it's a very excellent question, and that's also one of the keys of the framework that we developed, is not only to include the product and the process and the requirements, but also the performance of it. So cost and time aspects, to actually make sure that we can identify the best practice based on data. And the data that we used, or the way that we chose to do this, is in a quantitative way. So we chose about 50 past product development projects, and then took the actual data from those projects and put it in this framework. And thereby we have actually a quantitative approach to measuring and identifying the best practices and the impact of the best practices on cost and time. Yeah.
And just to make this best practices, do you build some community of practice, or?
Excuse me, you cut out again. Could you please repeat?
Yes, to get these best practices, did you organize some communities of practices or group of interactions?
Yes, we did. We were because of the scope of the paper, we were not able to put a lot of details into this paper. But since a year ago, when we submitted this paper, we wrote we go more into detail on the best practices that we actually identified in the collaboration company based on this framework that we presented here. And the paper is currently under review.
Okay. Thank you. Thank you, Georg.
Yeah.
So who wants to take the floor about my performance evaluation question?
Okay, I can respond to that. Actually, yeah, of course, the title mentioned efficient, and in our case, that was more a preliminary work in terms of implementation, you know. So based on the interviews that we made, we could see with the interviewees to gather their opinion about the speed of this process, etc. And there were anonymous. Every one of them that was more efficient in the way that it didn't require to go to get to collect every piece of information that would serve as an input for the framework. And due to with an upfront sensitivity analysis, we could clearly see that if it takes 1 hour to gather the data from an expert, etc., because we measure full-time equivalent hours in the company with the sensitivity analysis that is upfront and made by the decision analysis, we observed that we could save several hours. This depended on the decision problem, that's for sure, because we studied the 5 decision problems more very precisely. But that was maybe for each. On average, that was something like 3.5 hours that were saved just for the first iteration. So
your way of to measure was about time, right?
was the time to gather the data. Yeah.
Okay.
Yeah, and but it definitely needs further investigation for future work.
Okay. Thank you, Timothé. And Darren, do you want to add something concerning your job?
Yeah, only to say that, as I mentioned previously, it's important to know the requirements. And I think if you know what the system requirements are, whether it's heating, whether it's cooling, whether it's ventilation, try to, by understanding what those demands are and knowing what systems that are installed, it's possible to measure the performance and the benefits of those systems. Currently, because we don't know what the exact requirements are due to a lack of data, the system, we're not sure what the exact performance of the systems are, other than they are massively oversized. So by getting better, by understanding the data and obtaining better data on the demands, required demands, and measuring that against the install capacities of equipment, you'll be able to get a better reflection on what the performances are and how those performances can be improved.
Thank you very much. So we don't have any more questions. So I don't know if you want to add something more, or otherwise I suggest that we close the session now and we can meet again in 10 minutes in the reception hall for the closing session, and then we can join again on Gather Me. Is it okay for you? Yeah? Okay. To all of you, take care and see you soon.
Okay.
Thank you. Bye-bye.
Thank you. Okay. Bye.